be a pulley. Same situation. What is the acceleration of the system given MA, MB, and alpha? Let's imagine that the direction of motion is given to us, and I will always give it to you if I'm asking you to calculate the acceleration. Let's imagine that the direction of motion is that way. That is, MB is going to be bigger than MA in such a way that B is going to go down the inclined plane and A is going to go straight up. This is a very similar situation. We know we cannot consider A and B as one system, so let's do the exact same thing as before. Let's consider A as our system. If we consider A as our system, let's identify the external forces acting on it. The first one that comes to mind on the list is the weight. Its direction is down. The next one is the normal force, but A doesn't touch or is in contact with any surface, so no normal force. Third one is any pulling or pushing. Obviously, there is the same pulling force as before. Therefore, there is a tension up. All right. And that's it, same as before. Let's do object B. Because we know that if we write Newton's second law at this stage, we are going to be facing two unknowns, TA and A. So we need another system. Free body diagram on B. In this case, we have the weight, MPG. B is on the surface, which is inclined. Therefore, we know that there is a normal force which is perpendicular to that direction and acting on object B. Therefore, gotta be up. And then, of course, the third one on the list is pulling or pushing. In this case, there is a tension, pulling up. TB. And that's it. No mu K, no mu S are given, therefore no friction. Same as before, at this stage we realize, okay, I'm analyzing two systems and those two systems are in contact. Therefore, the contact can be analyzed through Newton's third law and the property of a massless pulley to allow us to drop the subscript and to equal those two to each other. So now we know we can write one equation for object A, two equations for object B, and we are facing three unknowns, T, NB, and A. Good. Now we can do the math. Let's complete each of those free body diagrams. I've put all my forces, I've put all my label. The last thing is pick a coordinate system. Are being told that the direction of motion is that way. Therefore, I'm going to pick the positive X for object A to go up. And Y perpendicular to it. And similarly, since object B is going down the inclined plane, I'm going to pick my positive X to go in the same direction and Y perpendicular to it. All right. Coordinate system free body diagram for A is complete because T is along X, MA, G is along X, but it's not for B. This is where we realize, okay, alpha is somewhere. The question is, where is it? Is alpha between MBG and positive X, or is it between MBG and negative Y? There's two ways to figure it out. If we take the general case where alpha is not 45, then you can recognize, oh, look, MBG is vertical, alpha is defined from the horizontal, therefore I can identify a right angle triangle, therefore alpha cannot possibly be between positive X and the weight. Because again, we're taking the general case where alpha is not 45. Hence, alpha is right here. Bang, done. But that trick doesn't work for every cases, so let's look at how we can figure out the position of those angles in any situation. The method is very simple. It's a two-step method. let's make it big and on the side. This is your inclined plane. And this is the force that you're interested in, the weight. And our current system is that way. Okay. First step, you are interested in W. So that's the one you should focus on. You have identified how alpha is created. Oh, question from Aaron. The Show's outline book you suggested us to get as great step by step, just like this. Oh, yeah. Oh, perfect. Awesome. Glad to hear. Yeah. Show's outline listed in the syllabus are the best. Best. So I'm glad that you like it. There should be a couple. There used to be a couple. Actually, it used to be like 10 or 20 of them in Hamilton Library on the annex second floor, at least for this course. But if it's not taken out, it may still be there. If not, we can look it up on eBay, Amazon, secondhand. Brand new, they should be $20, $10 on paperback. But I'm sure you can find secondhand. Or you can, investigate on the web and do your thing and find a PDF. Anyway, so how are we going to figure out the angle? First, identify the force that you're interested in. For us, it's W. And you know that W is straight down by property of the weight. Good. Second, identify the two lines that create that angle that you know is related to the force you're interested in. In this case, alpha is created by a line that is horizontal and one that is along the inclined plane. Okay, so we have identified those three lines. The line of direction of your force and the two lines created your angle, that creates your angle. First question you need to ask yourself is the force that I'm interested in perpendicular to which of those two lines that create that angle? In this case, it's the bottom one. This one, horizontal. Obviously, since we're dealing with the weight, by property, the weight is vertical. Therefore, we know that the weight is perpendicular to that line, one of those two lines that create that angle. Once you have identified that line, ignore it and ask yourself the second question. What about that remaining line? Is this remaining line perpendicular to your X or your Y? If it's perpendicular to your X, then the angle is between your force and the X-axis. If that remaining line is perpendicular to the Y-axis, as it is in this case, then the angle alpha is between your force and the Y-axis. Bang, done. That will always work. Two-step method. Feel safe. You will see other type of geometrical pattern. This angle is the same as that angle. Or you might see this, which means that this angle is the same as this angle, which again, as we reuse this, is the same as that angle. Those are very standard pattern. Okay, but this one will come back every time you have an inclined plane. So make sure you practice that two-step method, write it down carefully in whatever word that makes sense to you. Keep it next to you every time you practice problems, and every time you see a problem with an inclined plane, bang, you know you're gonna have to use that. Practice the two-step process, and as you practice it 1 time, 2 times, 3 times, 10 times, 20 times, then you will be able to do it in your head, and you will never miss the position of your angle alpha. Because if you miss it, then everything is wrong. So you don't want to mess up your Fibonacci diagram. It always got to be perfect. Questions on identifying where that stupid alpha angle is? Is everybody okay so far? You don't have to use that method if you're an expert in geometry from high school. So use it only if you need it. And I'm sorry, Tim, I totally missed your answer. Seems like you're in good shape. You don't need that stupid method. Thank you. All right. Okay, so let's make space and let's write down our equation. Okay, so first one, we only have one equation. Positive x is up, therefore t is positive in this case. minus MAG, and this must be equal to MA times A. And then for object B, that's back to chapter 2, so that's easy. Shouldn't take longer than 10 seconds. We are going to have the X component of the weight, which is MBG sin alpha and minus T, and that's it. And this will be equal to MB times A. And in the Y direction, we pick up, if this one is sine, then obviously the other one is cosine. But this one is negative, and then plus NB. And again, due to the choice of our coordinate system, such as we decided to align positive X into the positive acceleration of the system, we know right away that the acceleration perpendicular to that distance, which is our Y, is 0. And we have a nice little 0 in there. If you do not use that trick and you pick a standard X and Y, then remember that you will have to project not only your forces, but also your acceleration term in both your X and Y axis. So that sounds like a lot of work to me. But use both methods and figure out which one you like best. That's it. So what are we looking for? Acceleration. 1. Oops. 1 unknown here, 2 unknown here. Same unknown, so far so good. Same unknown, so far so good. So really, again, we don't need that guy. I take the habit of always writing both equations because as we're going to introduce friction, we're going to need all of them. But in this case, we just need equation 1 and equation 2. Easy. We're looking for A. We want to get rid of T. Obviously, T is positive here. T is negative here. So we can just add those two equations. And then that would be the end of it. We end up with negative MAG plus MBG sin alpha. And this will be equal to the sum of MAA plus MBA, which leads to solving for A and being equal to MB sine. There is a G common to both, so I can take it out, minus MA. And I divide again by the total inertia. All right, and sure enough, better be positive because I was given the direction of motion as A going up, B going down. So since I use that assumption in the choice of my coordinate system, I have to get a positive value. If I do get a negative value, then I know something went wrong. Okay? Questions?